Now, let's look at a very similar type of question here. I would recommend you to kind of stop the video and do it yourself, because it's nothing different except the fact that the drift is kind of towards the port and you are now 5 nautical miles to right of center line. And the third difference is the NDB is now behind the aircraft. So three differences, but the method is exactly the same. Alright, perfect. Now looking at this aircraft, the aircraft is flying a heading with 12 degrees port drift and making good a track 5 nautical miles to right of center line of the airway. Find the relative bearing of NDB situated center line of the airway 30 nautical miles behind. Now if you have gone to the previous question, it will be pretty clear here as well that we don't have a track to start with, but we have a drift, and you can either assume a track or you can assume a heading. Let me assume a heading again here. So we'll assume a heading. Let's make the heading, say for example 150 degrees here. You can take a heading of your convenience. You can probably take 90 degrees as well, but I'm just taking an off heading just to give you a different idea about the same, more to be a practical value, right? You can have any headings when you fly, right? So it's 150 degrees magnetic, right? Now this is basically an assumed heading, which means it doesn't really matter what heading you choose at the end of the day. Since they have asked you the relative bearing, your actual heading doesn't matter, right? So, or it should not matter when it comes to the answer. Now with this we apply the drift, but remember in this case we have 12 degrees of port drift, and therefore the track is to the left or port side of the heading. Go back to the previous question, we have detailed it very briefly there, and therefore that goes from the heading, which is 150 minus 12, and that's going to give you 138 degrees magnetic. Now another point to understand here, which we have already detailed in the previous question, if the heading is, also the drift is actually given plain or straight in the question, it's more appropriately the planned drift, and therefore what you get by applying planned drift to heading will be planned track, not track made good. That's what I'm trying to say. All right, now we have actually done questions where the drift is read from an ADF. I'll drop the link up here. You can check that out, where the drift taken is the actual drift, and therefore the track obtained will be track made good, or the actual track. Now since we have the track, now we have something to kind of draw, right? 138 degrees magnetic is the track of the aircraft, and that is with respect to navigation aid, which is an NDB. So let's draw the NDB here. I'm not kind of exaggerating the NDB diagram here. You know how it is. It's a dot with a solid circle and then 3 or more dotted circles around, right? The track we're looking at is 138 degrees. Let's draw the track here. All right, this is the track of 138 degrees magnetic. So you can see here aircraft on this particular side would be on a track of 138 degrees, but to the NDB, to the station, the aircraft on this particular side would be still on a track of 138 degrees, but now it will be moving from or away from the station. Now am I moving to the station or from the station? For that they have given a particular data towards the tail end of this particular question. You can see that the NDB is situated at the center line of the airway 30 nautical miles. Now keep a note of this, it's behind, which means the NDB is actually behind the aircraft, and for that reason the aircraft has to be moving away from the NDB. Now it's not yet time for you to place the aircraft, because the aircraft is not found on the planned track. Unfortunately we have a drift and we have gone off and is making good a track 5 nautical miles to the right of center line of the airway. So by drawing this particular track here, what we have actually drawn is the center line of the airway. That's what is called the airway. And we have seen in the previous question that the airway has a 5 nautical mile boundaries on either side, which is in line with the ICAO regulatory limitations, and therefore the aircraft being anywhere within this 5 nautical mile of the center line is still considered to be within the limits of the airway. And in this case, the aircraft is found to be 5 nautical miles right of center line, and now it is moving away from the NDB because the NDB is behind the aircraft, right? So we are looking at this particular region of the entire diagram. Let me just highlight it for a second, right? And the aircraft is found to be 5 nautical miles to the right. So having moving away from the NDB, so let me just show you that. away from the NDB. To be on its right, the aircraft has to be somewhere on this side. Right, so I hope you understood the area of consideration. The area of consideration is basically this side of the airway and the NDB. So let's get rid of all these. So let's draw a 30 nautical mile arc, just like in the previous question. This is the 30 nautical mile arc from the NDB, and now the aircraft is flying to be 5 nautical miles to right. This is 5 nautical miles off. You know where the question is going, right? But unlike in the previous question, the aircraft has not been flying parallel to the airway, because now the aircraft was supposed to fly at track 138 degrees outbound from the station, but somehow the aircraft went off to the right, and now the aircraft flew this particular track here. This is the track that the aircraft is currently flying. If the aircraft doesn't do anything about it, it's going to continuously move away from the airway, and once off 5 nautical miles, now it's out of the ICAO regulatory limitations. Right. So at this particular point, let's kind of place the aircraft. The aircraft is kind of at this point. See, the aircraft is 30 nautical miles from the NDB behind the aircraft, 5 nautical miles off to the right of the center line. So I hope all these things are kind of in line with the question. We have put that up in this diagram, and it is pretty much clear to you. Now let's place the aircraft. To place the aircraft, we need the heading, and the heading that we have assumed is right here, which is 150 degrees. So let's place the aircraft. You see how the order in which we are going. We first place a track, because that's any line drawn on a chart, Earth, it's all track, and then we kind of position the aircraft and then draw the aircraft. Right? Let's draw the aircraft now. The aircraft is on a heading of 150 degrees. So see how I'm drawing the aircraft and see if you can figure out why. So I'm placing the nose of the aircraft somewhere in this orientation. Let me draw dial as well real quick to complete the diagram. Right, and this, we are looking at a heading of 150 degrees. I'm just marking the heading there. Remember, it's nothing to do with the dial indication. The indication dial will be drawn separately. This is just the heading of the aircraft. You can see how 150 degrees more to the right of this 138 degrees which we have actually drawn here. The 138 degree line, and 150 is more towards the right of it, obviously. Right, now that's it. You have to find out the RBI indication. Now, just like in the previous question, you can see I can mark the head of the dial. Head of the dial is in line with the nose of the aircraft, and if we are looking at a relative bearing indicator, the head of the dial is going to be the nose of the aircraft, which is taken as reference and therefore marked 0. Right? Therefore, this is going to be 0 degrees. Now, the relative bearing, which is what the RBI measures, is always measured from the nose in the clockwise direction. Now, keep a note of this clockwise term here, because what I'm trying to tell you is to not measure it like this. That's going to be wrong. Always measure it clockwise from the nose all the way towards the NDB, because that is exactly what the ADF would be pointing to. Let's draw the ADF needle before that. So the ADF will always tell you where the NDB is. It's just going to point you towards the NDB. This is what the ADF needle will point towards. Right? Now, the relative bearing is always measured from the nose of the aircraft clockwise towards the NDB. Right? If you can find out this particular angle, that is going to be your RB indication. Now look at this particular diagram here. Now it's pretty much easy to understand if I tell you that if I take this particular segment here as such, that's going to be 180 degrees. Right? Let me get rid of that now. Therefore, if I can find out this smaller angle here, let me just highlight that now and subtract that from 180. I will eventually find out this particular angle. The heading of the aircraft is 150 degrees, which is right here. Now, what is this track we're looking at? If I can find out the track, and if I know the heading is 150, the difference between those two is the exact angle which I'm looking at. Subtract from 180 and you will get the RBI indication. So to find out this track, basically I have this track of 138 degrees, which is my planned track. I drifted off and I flew another track, which is what is appropriately called as the actual track or track made good. Right? Now the angle between the planned track and the track made good, this is the planned track, this is the track made good, measured from the planned track is what is called as track error. So to find the track error, just like the previous question, apply 1 in 60. But think about it, you are 30 nautical miles away from the NDB, 5 nautical miles off. As per 1 in 60, you have to be having a track error of 10 degrees, because 1 in 60 holds to the fact that 60 nautical miles away or 1 nautical mile off track would give you a track error of 1 degrees, right? Therefore, the track error is definitely going to be 10 degrees. If you want to use the equation, you can use the equation right here. So applying 1 in 60 to find out the track error, that's distance off, and since it's track error, it is distance gone already, and you multiply that with 60 and we will get the track error. Let's find out. The distance off is right here, which is 5 nautical miles, divided by the distance gone, which is 30 nautical miles from the station, and multiply with 60, and you'll be getting 10 degrees. As I said, you don't necessarily have to do it like this. At this particular point of your training, you should be able to kind of physically understand what a 1 in 60 is, and should be able to apply it without using the equation, especially when it's given in factors or multiples of 60. All right, perfect. Therefore, track error being 10 and your planned track being 138 degrees magnetic, we can see it's to the right, and therefore the track error is 10 degrees right, and therefore track made is going to be made good is going to be 138 plus 10, which is 148 degrees magnetic. Therefore, this particular track we're looking at is 148 degrees magnetic, the track which the aircraft would fly if it does not do anything about and correct for the drift. All right, perfect. Now we have a heading of 150 here, which is rightly mentioned here, and now we have the track made good of 148, and therefore the angle between the heading and track made good is a very small angle of 2 degrees. Right? So you can see here that you can kind of find the RBI indication in 2 different ways. Let's discuss both of them very quickly. Now, since it is 2 degrees, the rest of the angle we are looking at, which is right here, is going to be 180 degrees minus 2, which is 178 degrees, which is going to be your RBI indication. Let's draw that indication here from a pilot's perspective. So this is your aircraft here. We have the dial around the aircraft, and since we are looking at a relative bearing indicator, the heading is going to be 0, and now you can see the needle is going to point towards the NDB, and the NDB will be on a relative bearing of 178 degrees from the aircraft. Remember, this is not the track to be flown, it's just a relative bearing, the position of the NDB, or track of the NDB with respect to nose of the aircraft. Now, there's a different way of finding this out. Now, think about it. If you look at the current scenario, the heading of the aircraft, if I kind of pitch the heading down, the heading of the aircraft is 150 degrees magnetic. The track made good, the actual track flown by the aircraft is 148 degrees magnetic. And what does this tell you? If I give you the heading and track made good, you can kind of find out the actual drift, right? Because it is the actual drift that connects the heading and the actual track, or the track made good, and that is going to be 2 degrees. Obviously, the difference between 150 and 148 is 2 degrees, and since the track is now to the left of the heading, you can very well see that from the picture here, the track is to the left of the heading. It's going to be a port drift. Now think about it. Aircraft moving away from station, away from NDB with 2 degrees of port drift. What do you think is going to be the ADF indication? Again, you have to have your basic knowledge playing out here. The ADF indication, particularly the RBI indication, is going to be 180 minus 2, because it's 180 because you're moving away from the station, minus 2 because it's 2 degrees of port drift, and that's going to be 178 degrees. So you can actually find out this particular ADF indication as an RBI in both the methods. I would probably go with the second method, because it kind of gives me more understanding of the concept, that when I move away from an NDB with 2 degree port drift, the ADF is going to indicate 178, rather than having these math numbers being played in between, and the angles as well, right? Now let's look at the same thing. So the answer to the question is 178 degrees, which is the RBI indication. Let's look at what the indication would be if it was an RMI. The advantage of RMI is that the RMI kind of gives you the exact track to be flown if you want to reach towards the station, which is a QDM, right? So the head of the RMI, unlike in case of an RBI, radiomatic indicator, will be the heading itself, right? So let's play the heading here. The heading of the aircraft as an assumed heading is 150 degrees magnetic. As I've discussed earlier, RBI or RMI, it's always going to measure the relative bearing, and therefore the needle is going to point towards exactly the same orientation. You can see both the needles of RB and RMI are parallel at the same orientation, which means it is going to measure the same relative bearing of 178 degrees in both the cases. The difference is not in the measurement, it's more in the indication. Therefore, you have a heading of 150 in this case, and 178 degrees measured clockwise from 150 is nothing but adding heading to the relative bearing, and that's what gives you the QDM, magnetic track to the station. Therefore, that is 150 plus 178, which is 328 degrees. Not asked in this particular question, but this is what the RMI indication would be. Now, one small trick on RMI is if you look at the tail of the RMI. The tail of the RMI is also pretty useful. This is one of the advantages of using RMI over RBI, because the tail of the RBI is not going to indicate you much, but the tail of the RMI is going to indicate to the reciprocal track, which means if this 328 is the magnetic track to the station, which is QDM, that in the figure is more appropriately going to be the track from the aircraft towards the NDB, which I have just shown you here. The tail of the RMI is going to now show you the track in the opposite direction, which is from the NDB towards the aircraft, right? Therefore, that is 180 degrees to it, which is what is called as the QDR, or magnetic track from the station, which is something which we already have as 148 degrees magnetic. You can just subtract 180 from 328, or 180 add 180 to 328, you will get 148 degrees. So tail of the RMI is going to indicate you the QDR. This is the tail, and the head of the RMI is going to indicate you the QDM, which is not the case with the relative bearing. So basically, one of the advantages of RMI is that it can give you dual indications: head giving you QDM and tail giving you QDR. Depending upon what is your intention with the flying, you might use either of those. All right, very, very helpful for plotting. If you have the variation, you can convert these to true before you kind of put them into the chart and kind of find out where you are.